and welcome to the latest edition of our Sustainability Perspectives podcast. My name is Elisabeth Skura, and today we'll take a deep dive into fiber-based packaging and in particular into dry molding fiber technology with U2Eco. And we'll explore advantages and challenges of the technology, the potential to scale up, and we'll also take a look at recent developments and technological advances. So with me to do this is Jerome Zhang, who is Senior Research and Development Engineer at U2Eco. So welcome, Jerome. Thank you very much for being on the podcast today.
Thank you, Elizabeth. Hello, everyone. This is Jerome Zhang from U2Eco R&D Institute. U2Eco is actually a sub-brand of U2 family. We're driven by a strong commitment to sustainability and determination to transform traditional packaging standards. Our concept is to turning waste into treasure and make efficient use of natural resources. So sustainability is a guiding force in every aspect of our brand, from conceptualization to production and delivery.
To get us started, I wanted to ask you, what drives the increase in demand for fiber-based packaging? As obviously we've seen a big increase in recent years.
Yeah, of course. Presently, as we all know, plastic dominates the packaging industry because of its desirable properties like lightweight, durability, and practicality. However, it also poses severe environmental threats. According to 2021 United Nations report, around 9.2 billion tons of plastic were produced from 1950 to 2070, with less than 10% recycled. That means 7 billion tons become plastic waste. And estimates suggest that by 2040, that will be more than 700 million tons of plastic waste will be discarded. And on the other hand, in May 2019, the International Center for Environment released a report. I remember it's titled Plastic and the Climate, the Hidden Cost of a Plastic Planet. In it is stating that plastic originates from fossil fuel and emits greenhouse gases through its life cycle, which contributing a lot to the climate change. Plastic industry consumes 8 to 9% of the world air annually. The stage where it converts resin into plastic products alone accounts for 1% of global carbon emission. So in conclusion, plastic production are exacerbating the three global crises of climate change, natural degeneration, and pollution. If left unchecked, this could lead to disaster. Governments worldwide are intensifying efforts to regulate single-use plastic products, and the packaging industry is the first to be affected. Besides, many consumer brands have also voluntarily announced their commitment to alternative packaging material. So, finding an eco-friendly alternative material is an urgent demand of the packaging industry. In this context, plant-based fiber material have once again gained attention globally. Fiber-based packaging offers performance comparable to plastic, especially with the thriving of pulp molding products, which can have intricate structure and appealing designs, make it an excellent solution for replacing like injection molding or blister plastic products. This has fueled rapid growth in fiber-based packaging over recent years.
Yes, that makes a lot of sense. And following on from that, obviously U2Eco focuses on dry molding fiber technology. And what are the general advantages of this technology compared to wet press molding and wet fiber molding?
Compared to wet fiber molding processes, dry molding processes offer significant advantage in terms of energy efficiency, production efficiency, and the diversity of raw materials that can be used. Wet fiber molding is considered a significant improvement in energy efficiency and carbon reduction comparing to petroleum-based plastic. And the dry process building upon the wet process further decrease energy consumption estimated by 40 to 70%, substantially reducing carbon emission. And simultaneously, the dry process saves time by shortening the time-constrained processes, resulting in a substantial increase in overall production efficiency. In practical application, the dry fiber molding process eliminates the need for a complex pulping preparation system in the upstream and improves the production efficiency of individual machines. This allows for highly efficient production of products in a very compact facility, less than maybe 1/10 of the current area. For instance, it is possible to integrate fiber molding production line into the same workshop of final product packaging, or setting up a disposable tableware production facility in areas with concentrated food and beverage establishment that was unimaginable in the past.
Conversely, I also wanted to know, are there any challenges around the process?
As far as we know, most dry fiber molding technology currently available on the market are all facing some similar technical challenges. For example, fiber dispersion is difficult to control. It may lead to poor thickness consistency, and the flatness of packaging surface is also not yet comparable to that of wet molding counterparts. And the barrier property also need to be improved, like always. So we actively working on this technology to further optimize our technology to solve these three problems.
That sounds good. And I wanted to zoom in a bit more on the individual technologies. Could you tell me a bit more about extra fiber, which is Südzucker's pioneering extrusion fiber technology, and its advantages?
Certainly, it's a combination of extrusion and fiber. It involves around blending fibers with bio-based additive to create a flowable colloid, which is then extruded into a mold to produce the final products. Compared with other dry fiber molding process, which already are available on the market, it can produce deeper structure and generate less cutting waste and offer better material adaptability. It is also essential to distinguish Itrolib from certain purportedly eco-friendly products on the market, such as bamboo or wood plastic, which also undergo injection molding. In these products, traditional petroleum-based plastic constitute the primary component, with plant fiber serving only as additive to replace a fraction of the plastic. These items are often considered deceptive in their environmental claims by misleading consumers that they are all plant-based. That is also a violation of laws in some areas, such as European Union. Conversely, Eco's Itrolib is composed mainly of plant fibers with only a minimal amount of bio-based and naturally degradable additives to improve fluidity. This clear distinction established Itrolib as a genuinely sustainable alternative in the package industry.
That sounds great. That brings me to the question, what are the main hurdles that still need to be overcome to scale technologies such as extra fiber globally?
Like most newly developed technology, dry fiber molding products currently have relatively high costs. You can imagine that it consists maybe two parts. One is high investment in equipment, another is high raw material cost. This may be the biggest hurdle hindering the rapid adoption of this technology currently. To address these issues, in our opinions, collaborative efforts across the entire supply chain are necessary. For example, stakeholders could jointly bear the initial equipment investment costs and recoup returns through future profit sharing mechanisms, thereby lowering the barrier to entry for manufacturers. Another effort can be made is using like policy guidance or price subsidies or value promotion to help manufacturers quickly overcome the initial production ramp-up phase and enter large-scale mass production, thereby reducing raw material and the production cost through economy of scale and achieving a price advantage. Of course, from our R&D perspective, seeking more economical raw material and developing more efficient production process remain our eternal pursuit.
Yes, and obviously we'll stay in touch and see how it goes over the years and watch the technology grow and expand. I wanted to ask you about a different technology that you've developed, the Ecolucent membrane, which is a transparent solution for plant fiber packaging. And yeah, I was curious to find out what its properties are and how you achieve this transparency.
Yeah, Ecolucent membrane boasts several key features. The first one is it's a cellulose material, so it enables plastic-free packaging. Second, it's made from natural plant-based resource, which is fully biodegradable. Third, it has a very high transparency, normally more than 90%, which is comparable to conventional PET films, allowing visible content in the package, which is its mainly application in packaging industry. And also it can be coated for multiple functions like anti-fall, hot heat sealing, or anti-static properties. And last but not least is our Ecolucent membrane is made from the ionic liquid forming process, which is more eco-friendly than traditional viscose process. For the second question, to explain how we achieve its transparency, I may need to deep dive a little bit into the technical details. First, our processing enhances the orderliness of the cellulose molecular structure. Cellulose films comes by our lucent membrane, constitutes crystalline and amorphous region. Crystalline region allow light to penetrate more easily, while proportion of amorphous region is reduced after our processing. Second, processing improves the uniformity of microstructure. The membrane consists of cellulose microfibril with diameter in a nanometer range, normally approximately 5 to 20 nanometer. The size of these fibrils is far smaller than the wavelength of visible light, which is around 400 to 700 nanometer. And according to the Rayleigh scattering principle, when the size of scattering particle is far smaller than the wavelength of light, the scattering effect is significantly weakened, thereby improving transparency. And finally, processing removes impurity. We can imagine that natural cellulose often coexists with like lignin or hemicellulose or other ingredients which absorb or scatter light. For example, lignin is commonly known have a brownish red color. During the manufacture of cellulose, impurities are removed through the dissolution and purification stage, resulting in significantly improved light transmittancy in the membrane. These facts collectively contribute to the high transparency of the Ecolucent.
That's really interesting. Thank you. I'd also like to talk about the Flow Zero technology, which is designed to make molded fiber packaging stronger. And could you tell me a bit more about its properties and applications as well?
Yes, that's another interesting story. Our initial goal in developing Flow Zero was to achieve oil resistance in pulp molding food packaging. And we did indeed obtain a product with a wide oil resistance temperature range from 0 to 220 Celsius, and the long oil resistance time, more than 3 hours. And luckily, during the R&D process, we discovered that this technology could also significantly improve the strength of moulding fiber packaging. Based on one of our test results, after introducing this technology, the product thickness decreased by 8%, while the bending stiffness increased by 107%, and the burst strength increased by 147%. This allows us to use it in wider range of packaging than the food packaging, which provide better protective performance and contribute to weight and carbon reduction.
You mentioned previously as well that Utilica uses unconventional fiber sources such like rice husks and coconut shell and others. How scalable and commercially viable would you say agro-industrial waste streams in high volume packaging applications?
From our experience, we've learned that the biggest challenge in using waste material for packaging is getting a steady, low-cost supply. Actually, there are already been a lot of people ask us about using corn stalk or wheat stalk from rural area because they are so abundant and cheap, sometimes free. But collecting and transporting them to the packaging facility comes with significant logistical challenges. Plus, since these crops harvests happen seasonally, that means there are times when these raw material aren't as readily available, so we need storage solution to ensure we can produce year-round. These extra costs can end up making waste material even more expensive than conventional wood pulp. That is a big obstacle to scalable application. So to get around this issue, Yuto is trying a different approach. Instead of collecting those waste from scattered farm, we are forming partnership with companies that they produce those waste as part of their regular operations, like food or feed processors. For example, one of our products is made by bamboo shoot shield, which is a waste from food industry. So by teaming up with these companies, we can tap into these resources while keeping our production process running smooth.
Sounds like a great process. My final question to wrap up and summarize. From your perspective, how close are we to molded fiber packaging being a true one-to-one plastic replacement in high barrier, high volume consumer applications?
We can see that even though there's been a noticeable move toward plant-based products, especially molded fiber products. However, according to some third-party research we have seen, there's only about 6 to 10% of plastic items have been replaced by paper products. Do remember that's not just fiber molding package. It also includes those flat paper like paper bags, boxes, or even the paper straw. So it clearly shows that there's still a huge opportunity for plant-based packaging solutions to grow. One area with a lot of potential may be the high barrier, high capacity products like beverage or household chemicals or even medicines, which still rely heavily on plastic bottles or containers. So to really make a difference in this industry, I think we need to improve several key features of paper packaging. For instance, the barrier performance, especially when it comes to the shelf life, it is very crucial. So by doing this, maybe we can encourage more industries to adopt sustainable packaging, such as molded fiber packaging. then lead to a greener future.
Hopefully that will be a development that's coming in the packaging industry even more than it is already today. Great. So that brings us to the end of today's podcast. Thank you very much, Jerome, for being here today and for sharing your insights. Thank you for a really interesting conversation.
My pleasure.
Thank you. And if you'd like to hear more about dry molded fiber technology from Utoeco or generally take a deep dive into sustainable packaging, make sure to attend Packaging Europe's Sustainable Packaging Summit. And this year's event will take place in Utrecht in the Netherlands from November 10th to November 12th. And we'll have 3 days packed full of content session and expanded lineup of speakers and exhibitors and attendees from across the value chain. If this sounds of interest, I'll put a link so you can find out how to get your tickets.